Hey, what's up everybody, and welcome back to another part of this Algorithmic Patterns course. In this part of the course, we're going to apply the sliding window pattern to this Leetcode problem here. This problem is yet another problem from our Leetcode patterns list, which can be found by filtering the list like so. This problem asks us to find the longest substring without repeating characters. Similar to the problem in the last part of this course where we had to find the maximum number of trees that we could pick from, the size of our window is going to be dynamic in that it will adjust with the number of non-repeating characters in the substring. Just like the last problem's window size changed with the number of trees that could be picked from. At this point, you should be starting to recognize a pattern. That is, when we're asked to find contiguous sets of items given some criteria, for example, contiguous trees that are of one of two fruit types or contiguous characters that do not repeat, the sliding window pattern can usually be applied. So let's take a second to visualize how a dynamically sized window can be applied here. Let's imagine that we have a string that looks like this. So if both the start and the end of our window start at the first character of our string, our window would progress to the end of our string like so, dynamically resizing when necessary to stay within the constraints of the problem. As you can see, there are 3 substrings in this string greater than length 1 that conform to the constraints of the problem. That is, there are 3 substrings that do not contain repeating characters. As you can also see, our window shifted dynamically to capture all 3 of these. Now all that's left is to keep track of which of these substrings is the largest. Now let's write some code to replicate this behavior. Okay, so let's go ahead and write up some code here. Back in our YouTube patterns directory, we're going to create a file called longest_substring_without_repeat.go. I know it's kind of a long file name, but I just want it to be verbose. And within this file, I'm actually going to copy over some of the code from our fruit into basket file. So I'll go ahead and take everything up until the end of our main function. And I'm just going to paste that into this file. And then we'll save that file and quit. And now we're just going to remove our fruit into basket file. And we can just go mod tidy and then clear. And now we go back into our longest substring without repeat file, and we're going to change the function here to longest substring without repeat. And the input to this function is going to be a string s, and we will start with this string for our example, pwwkew. And into the function we'll pass s, and then of course after we get our answer we will print our answer. So now let's go ahead and create this function. So under our main func we'll just create a func longest substring without repeat, and it's going to take in s, which is a string, and we're going to return an int. And to start, we're going to create a map data structure, which is going to be used to keep track of characters that we've already seen within a substring. So we'll do char map equals make, and we're going to make a new map, a new empty map, which is going to have byte as the keys and bool as the values. And byte is just going to be the character, and bool is going to be whether or not we've seen the character before within our current substring. And then we'll do longest sub length equals 0, and we'll also do start equals 0. And we're going to start with a for loop. Similar to our previous problems, we're going to use end as the variable that represents the index that we are on when iterating. And we'll do range s. We're going to loop through the string s. So similar to an array, we can loop through a string as well, loop through each character of a string as well. And each character within the string is going to be indexed, of course. So you can essentially just think of a string as an array of characters, because that's actually what it is. And then we'll do char equals whatever character is at our end. So our current character is going to be this char variable. And the first thing we're going to do is we're going to check if the current character exists within our map already. So we'll do if not char map char. So if the character does not exist within our map, we want to add it. So we'll do char map char equals true. So this is how we're adding a character to our char map. And once we add that character, we want to get our largest sub length by comparing our current sub length to the current window size. So we'll do int math.max, and we're going to compare float64 largest sub length, which is going to be our current maximum substring length. And we're going to compare it to float64 end minus start plus 1. And if you remember from our previous two problems, end minus start plus 1 will get us the current window size. So we want to compare our current window size to the largest sub length, which is the largest window size that we've seen thus far. And we also need to go up here and import math. And then we can go back down here. And it seems we're having an issue here, undeclared name largest sub length. And that's because up here I named it longest sub length. So let's just change this to largest sub length. So we're going to do this if the character does not exist within our map. But if the character does exist within our map, we're going to create a while loop essentially. So we'll do for char map char. So this, although it's using for, is actually a while loop. So it's basically saying while our current character still exists within our character map, we want to do the code in here. And what we want to do is we want to do char map the character at our start equals false. And then we want to increment our start. And this part is a bit confusing. If you don't understand it right now, don't worry. I'm going to explain it in a visualization of the code in a little bit. So I will make this more clear in the visualization. So just bear with me for now. And after we've looped while this condition is true, once this condition is no longer true, we're going to set our character map current character equal to true. And once again, I know it's confusing, just bear with me. And then at the end, we're just going to return an integer of the largest sub length. And that is going to be the end of our algorithm and our function. So let's go ahead and save this. And then we could do go run longest substring without repeat. And we get 3, which is the answer to the problem when taking into consideration this string as the input. The longest substring here without repeat is going to be this substring here, WKE, or even this one, but 3 is going to be the longest substring without repeat within this string. So now let's go ahead and go into the visualization. Let's go ahead and clear this and go into the visualization. Okay, so let's take some time to go over this code. So we're going to imagine that we have the same input string here, which is going to be equal to PWWKEW. And remember, when iterating through a string, we can think of it as an array of characters. So we can actually add indexes to each character within this string. So we'll do 0, 1, 2, 3, 4, 5. And these are the indexes for this string. And that's going to be what's passed into this function here. And we're going to start by creating an empty character map. And the character map is going to have its keys as bytes and its values as bools. And the bytes are just going to be each individual character of our string. And our largest sub length, which is the largest substring length, is going to start off as 0. Our start is also going to start off as 0. And let's remember, the way we actually visualize our window in code is by using a start pointer and an end pointer. So at the beginning, our start is going to be pointing here at the first character of our string, and at the beginning our end is also going to be pointing here at the first character of our string. So that means that our window is just this 0 here. Our window has only one item in it. And to represent our window, we can just use a line here. So this is our window. This green line here is our window. And as we loop through the string, our window is going to both expand and shrink in size depending on the constraints of our problem. So the substrings within this string cannot contain repeating characters. So as long as the characters adjacent to one another don't repeat, then that means that we can continue to expand the size of our window. So let's go ahead and start iterating through our for loop. We'll start here at the beginning of our for loop. Our end is going to start off as 0, our first index of our string. So we're going to set our character equal to the character at this index of our string. So if our end starts off as 0, we can go ahead and write that out actually. So if our end equals 0, then that means the character at the 0th index of our string s is going to be our character. So the 0th index, we have the character p. So our character here is p. So we'll do character equals p. And then we'll come down to this if statement here, and we're going to check to see if our character already exists within our character map. And at the start of this for loop, our character map is going to be empty. So let's go ahead and draw out an empty character map. We'll do down here char map, and it's just going to be this empty map here. And actually it will probably need to be bigger, so let's go ahead and put char map up here, and it's going to be this empty map. So here we're going to check to see if our character p is contained within our character map, and if it's not, then we're going to do this code here. So our character p is not contained within our empty map because our map is empty, so we're going to add it to our map. And the way we're going to do that is by adding the character as a key to the map and setting it equal to true. So that's going to look like this. So we'll add p and then true. And this else, we're not going to do any of this because we already did this. So we're just going to go back to the top of our for loop, and our end is going to increment to 1. And our p is also going to change. It's going to become the character at index 1, which is w. So our end is actually going to move up. So at this point, our window is increasing in size. It's expanding. So our window is going to expand to here because our end is going to move to this 1. And once again, we're going to check to see if our character is contained within this map. And it's not. So we're going to add it here. So we'll go ahead and add w and then true. So you should start to see what this character map is actually doing. It's keeping track of the characters that we've already seen, so that once we get to a point where we are at a character that we've already seen before, that means that we're no longer within a substring without repeating characters. So let me just show you what that looks like. Oh, and actually in the last step, I forgot to write out this line of code as well. This line of code is setting our largest sub length equal to whatever is greater, our current window size or the current largest sub length. So let's just rewind for a bit. When we were here at index 0 at p, and we added p to our character map, we then should have gone down here to this line to check to see which is greater, our largest sub length or our window size, our current window size. So if you remember, n minus start plus 1 gets us our current window size. And when we were at this index here, our window size was only 1 because we only had index 0 in our window. So 1 was greater than the largest sublength here. So at the previous iteration, this should have been set to 1. So we'll go ahead and X that one out and just put a 1 there. But now we're at this iteration. Sorry for the confusion. If it's confusing, please just rewind the video. And we just finished adding our character W to our character map. And then we need to set our largest sublength equal to whichever is greater, our largest sublength or our current window size. So let me just show you guys how this current window size is working in case you haven't seen the previous videos. So basically this little n minus start plus 1 will get us our current window size. We're going to subtract the index start from the index end and then add 1 to it. So to get the window size for this window, the start of our window is here, the end of our window is here. We're going to do 1 because our end is at index 1, minus 0 because our start is index 0, and then plus 1 equals 2. And as you see, our window is 1, 2 items. Our window is size 2. So this gets us our current window size. And if you don't believe me, you can check it for any range of indexes. You'll get the window size if you use end minus start plus 1. So now we can go ahead and erase this. And clearly the size 2 is greater than 1. So we're just going to go ahead and change this to 2. And actually, let's just erase this. So this is 2. And once again, we're not going to do this. We're just going to go back to the top of our loop. And our end is going to change to 2. So we can just erase this 1, change it to 2. And our character is going to be changed to the character that is at index 2. But first, let's also change this pointer to point to index 2, which means our window also got bigger. But this window isn't going to be the window that we use to calculate this, because now this window contains repeating characters. There's 2 W's within this substring. So we need to shrink this window. So our character here is going to be W, and we're going to check to see if the character W exists within our character map, and it does here. So that means we're not going to do this, we're going to do this. So we're going to get to our else statement here, and this for char map char, just imagine that this is a while loop. So actually, I'm just going to change it to while. So while our current character exists within the char map, so our current character W exists within the char map. So while our current character still exists within the char map, we're going to do this code here. And what this code is going to do is it's going to take the character at the start of our window within our char map, and it's going to set it to false. So our current start is index 0, and the character P is our current start. So our window currently starts here. So we're going to take the character P and set it equal to false. So this character is no longer going to be true. It's going to be false. And our start, we're going to increment our start. So our start is no longer going to be 0. It's going to become 1. So we can just erase this pointer and increment it. Then once again, we'll check this condition. If our character map, the current character, still exists within our character map, we do this code. So P no longer exists within the character map, but W still does. So we still have to do this code once again. So we need to take the character at our start. Our current start is index 1, and the character there is W, and we need to set that equal to false. So we need to set W equal to false. And then once again, we need to increment our start. So start's going to go from 1 to 2. And we'll move this pointer to point to index 2. And now at this point, we'll no longer loop through this while loop because this condition is no longer true. Because our current character W would resolve to false because these are bools, and it would resolve to false. So once we finish this while loop, we want to add our current character back to our character map. So once again, this is going to change, but it's going to change back to true. And our window size is going to shrink up until 2. And as you can see, what that did is it started our substring at W here, and it removed this part, these 2 parts from our substring. Because if we were to keep both of these contiguous characters with this W, we would have 2 repeating characters within our substring. So we need to resize the substring, shrink it until we no longer have this repeating character within our substring. So now our window is only of size 1, and we're here at index 2. And we go back up to the top of our for loop, and our 2 is going to change to 3. And of course, our W, the character, is also going to change to the character that's at index 3, which is K. And we can also go ahead and move our end pointer up until 3. And our window is going to expand here. And then we're going to check to see if the character K exists within our character map. It does not. We only have the character W in our character map currently. So that means we're going to add the character K. So we'll do K true. And now we're going to calculate our largest sublength. So our current largest sublength is 2, and our current window size is also 2. So this isn't going to change. It's going to remain 2. And we're not going to do this, and we'll go back up to the top of this for loop and increment our end to 4. And that also means that our k is going to change to the character that's at index 4. So the character at index 4 is e. So since our end is 4, we can also move this end pointer up to 4, expand our window here, and our character is equal to the character at index 4, which is e. And we come down here and check to see if e is in our character map. It's not, so we add it. So we'll do e, true. And then once again, we're going to compare our current window size with the largest sublength. So our largest sublength is currently 2, and our current window size is currently 3. There are 3 items in our window currently. This is our window. So this is going to change to 3. And we're not going to do this once again. And then back to the top of the for loop we go, where we change our end to 5. So we can move this pointer up to 5, and our current window size will go up as well, and our character will become W. And even though we expanded the window here, it's not going to matter because we're going to get to this line here where we're checking to see if the character W is in our character map. And if it's not, we would do this code, but the character W does exist within this character map. So we're not going to do this code, we're going to go down to this code because we have W here. So when we get to this code here, while the character W exists within our character map, we're going to set the character at our start equal to false. So our current start is 2, and we're going to set the character W equal to false, and then increment our start. So our W becomes false, and our start increments 1. So from 2 to 3. And our window shrinks. And since the character that we just made false was W, and W is our current character here, we will no longer do this while loop because this condition is no longer true. So then once again, we'll go down to here and add our character at the current character back to our map. So this will become true again. And once this is done, we'll go back to the top of our for loop. But at this point, we're not going to increment our end anymore because we're at the end of our string. So this for loop would actually just terminate. So we're actually never even going to take into consideration the size of this window here. Because if you think about it, even in the worst case, within this else block here, our window size would never be greater than the previous window size when we had WKE as our substring. And let me just show you what I mean by that. So if we were to put this back to WKE, at the point where our end hits this W, and that's a repeated character that's already within this substring, the previous time we saw this character can be positioned in one of 2 extremes. So like it can either be positioned at the beginning of our previous substring, or it can be positioned right before it's repeated. And in the case where it's positioned right before it's repeated, then we would have to shrink our substring all the way up until right before it's repeated, which means that this next window would be smaller than our previous window size of 3. And the other extreme is if it's at the beginning, which is where it is. If it's at the beginning, then that means that at most, this next window, while we're still in this else block, at most can only be equal to this previous window size. And that's because if the repeated character, the first instance of the repeated character is the first character in the previous substring, which is what it is, then we'd essentially just shift our window over. We wouldn't expand the size of the window, we just shift it over. So since this first instance of our repeated character W is at the beginning of our previous substring, this while loop would only iterate once, which means that it would just remove the first instance of W from our character map and then it would just shrink our window by incrementing our start once, which is what happens. We end up shrinking our window here, and we end up expanding our window at the end here. So we're essentially just shifting the window from WKE over to KEW, which means our window size is the same. So within this block here, we don't need to calculate the window size again because it will never be greater than the previous window size. If we reach a repeated character, this while loop here will never expand our window to a size greater than the previous window size before we reached the repeated character. So the only time we would be able to expand the window is in this first if statement here. But in our case, we've reached the end of our string. So we've reached the end of our for loop, so we would never touch this if statement again once we've reached this point where our window size is of size 3 at the end of our string. So that's why here, after we do this and we get another window size of 3, we don't do our largest sub length calculation because it can't be greater than the previous substring length in this case. So in my opinion, the most difficult part of this algorithm to understand is this while loop here. And essentially what this while loop is doing is it's resizing our window. And exactly how it's doing it is, the way we resize the window is we just increment the start, because we can't expand our window backwards. For example, we can't expand the window in this direction. We only can expand the window in this direction. So actually this code here is only capable of shrinking our window. And we do that by incrementing our start. So if we want to shrink this window here, our start is 3. If we change our start to 4, our window would shrink. And our window would only be these 2 elements instead of these 3. And this part is just making sure our character map stays up to date. Because remember, our character map just keeps track of characters that we've already seen, so that we know when we've reached a character that's not unique within our substring. Because remember, our substring has to contain non-repeating characters. So as we're shrinking our window by incrementing our start, we want to remove the characters from our character map or set them to false, which means that they're essentially removed. When we check to see if the value exists within the character map, it would return a bool false. So as we shrink our window, we have to make sure we're removing the character that we subtract from our window from our character map as well, because our window represents the substring of non-repeating characters. So if we remove a character from our substring of non-repeating characters, that means that within that substring, we've never seen that character before. So we have to set it equal to false, which means that we no longer recognize that character as a character that exists within our substring. So that's what this while loop is doing. This while loop is to shrink our window. And then this code here after the loop sets the character back to true because the character still exists here. So that's why we had to set w equal to false and then to true. I hope that makes sense. So back to this for loop. So we finished this for loop because we reached the end of our string here. So we would then go down here. We'd no longer do the code in this for loop. We'd just go down here to our return. And at that point, we'd return our largest sublength as an integer. And our largest sublength is 3. So for this input string in particular, the largest substring length is 3. And as you can see within this string, there is no substring without repeating characters that's greater than the size 3. And that is how this algorithm is working. Okay, so at this point we can briefly go over the time complexity for this function. So when taking the time complexity into consideration, we need to consider both our start and our in are going to need to iterate through our array of characters or our string. And in the best case, our entire string will contain non-repeating characters. So there would be no repeating characters within the string. So the entire string would be a contiguous array of characters without repeating characters. And in that situation, our start would never move beyond the first index of the string. And that's because our end would just keep adding and adding and adding characters to our window until the entire string is the size of our window. So that would mean that our start never would need to increment here. So in that case, our start wouldn't need to iterate through the entirety of n. But in the worst case, which is what we want to consider when taking big O into consideration, so let's go ahead and write big O. So in the worst case, our start would need to increment all the way up until the end of our string. And even though it might not necessarily hit the final index of our string, there's a chance that it could more or less end up iterating through most of the string. And that's all we really need to take into consideration when we're thinking in big O terms. So with that in mind, both our start and our end could potentially iterate through the entirety of n, more or less. So we'll have this n here for the iterations that our start has to do, and we'll add that to another n, which would be the n for this end that needs to iterate through our array of characters as well. So the time complexity for this function would be O of n plus n, which is the same as O of 2 times n. And in big O, we ignore constants, so this just becomes O of n. So that would be the time complexity for this function. And as for our space complexity, so let's just go ahead and write this out. This is time complexity. And for our space complexity, we need to take our char map into consideration. So once again, we can write out our O. And our character map could potentially need to store every character, because even when we remove characters by changing the value to false, we still need to store the data for that character. So in the worst case, we could need to add every character of the string or our array of characters to our character map, meaning that our space complexity for this function in particular is going to be O of n as well. And that's because the space required for this function will scale linearly with the size of our input string or array of characters, if you like to think about it that way. So if the string passed to this function is 1,000 characters long, in the worst case, we would need to store all 1,000 characters in our character map. And technically, the repeated characters only get stored in our character map once. So for example, for this string here, we wouldn't have to store the W twice, because we would just change the value from true to false in this character map every time we update our character map for this particular character. So actually, the worst case in this particular situation for our space complexity would be an input string that has no repeating characters, which would mean in that case, we would add every character to our character map as true. So we would need to store every character of our input in. So it would scale linearly with the size of our input in. And that is the time and space complexity of this algorithm and of this function. And that is going to be it for this problem. Next, we will go over one more sliding window problem to further solidify our understanding of the pattern. And at that point, you all should have a solid understanding of the sliding window pattern and how to apply it and how to identify problems that are suitable for making use of this pattern.